Anthony from RIPE is our next speaker. Welcome.
Hi, good afternoon everyone. I'm Anthony, working on at RIPE NCC on the project Routing Information Service. Today I'm going to talk about the project, what were the motivations for the RIS and the status of the project and the prototype. Can you hear me now? Yeah. Okay, that's good. Motivations and goals of RIS, status of project, and prototype that we have set up for this project, and some interesting results so far we have seen from the project prototype and the future developments of RIS. The motivation, well, this morning most of you have seen like how well the BGP works, and it's kind of every model, and how long we can go ahead with that. It's time to look at it, and a lot of the results with Craig as shown in the morning could have been actually seen in this if this RIS was in place, and you can yourself have a look at this data. We believe that the BGP announcements are originating from independent sources, and we are at the networks which are at the faraway points can never trace it unless you go back to the origin from the remote points where you hear it. So you need to follow it back and see what was the problems and why it happened and so on and so on. So what essentially this is going to tell you is where you would have been, where you would have been routed yesterday on the autonomous system basis. So this will help you to check against the policies which are in the routing registry databases, or against what you really wanted is what's going on or not. So with this, we started a goal, like we want to have initially an interactive query, which is essentially probably a giant looking glass which cannot send any packets, but it has a history of BGP updates, where you can go back in time and ask for what was the state of a routing table from a point A to point B, and which is essentially the aim is. So we'll provide an interactive tool query which is command line as well as a web-based interface. We'll also provide raw data who's interested in that, and probably you can run it on other tools or other softwares which can take it. So how do we do this? We want to collect a default free BGP updates from core locations on the internet, which is what routes inter-domain routing is about. So we want to make this available to the internet community. So the possible queries to this database is still to be defined, and you as a user can ask for it, or we will discuss it and what can be implemented. Initial thoughts are to query on prefix. How was a prefix yesterday for a period of time? How did it change over a period of time? And same goes for AS origin. So you want to see an AS number, which is AS333, this is RIPE NCC AS. How was this performing yesterday, and how many prefixes announced, and how many of them are flapping yesterday. So some other things which we still haven't have the clear idea of this exact crystallized ideas are flap statistics, prefixes, how does it develop over a period of time, and more queries you can request, and we will be happy to implement them. The project is a pretty young project. We started 6 months ago, almost in July 1999. We started with a design document which was available on the website, and then sometime in October we set up a first root collector to collect the BGP updates and started putting them into database. So now we have around roughly 10 peers peering with the root collector. And in February, now we are in the RIPE meeting, RIPE 35, we plan to announce this query tool for beta testers and test it. We want to set up a few more BGP sessions, and in sometime in May, that is RIPE 36 in Budapest, we want to have more peers and define well formally how the user interface should look like. So for this, we have come out with the final setup. What we are planning is at each exchange points, you see in the exchange points, we put a remote collector which peer BGP sessions with all the possible peers out there. which gets a BGP feed from them. Since we cannot be everywhere, we also will have some eBGP sessions running from a default free border routers and NSPs. All this data is collected to RIPE NCC central collector, where we have BGP updates and the snapshots of the rig which we are collecting. All this is inserted in the database where you can query it as a command line interface or a CGI or web forms. So how do we collect the data? We have autonomous system numbers is 12,654. We will peer with all the possible peers at an exchange point and few eBGP points. And we plan the initial estimate is to go for say 10 such major collectors in the RIPE NCC region, which is pretty much Europe and some other neighboring parts. And each exchange we estimate 70 peers or so. So each of these peers announcing whole routing table to presumably of 70,000 prefixes. So the remote route collector, which is shown in the previous figure, was what it does is it collects BGP for announcements and time with AS paths and other BGP attributes and timestamp it and save it in a binary format. We also take snapshots, which is to create a state of a routing table. So we essentially load a snapshot, and from there we do the deltas to reach a state, any given state time. So this route collectors don't announce any routes, not forward any traffic. It just listens there. So this was the final set that we want to achieve, and then for that we want to see how feasible this whole project was. And so we set up a prototype which is running since October 1999. So far we have 10 peers, and which is from 8 distinct autonomous systems. And the collector we are using is at the moment is MRT, developed by Merit. And from there we put the data into a database and index it so that you can send different queries to it. So the raw data plus snapshots and the index data comes to roughly 40 megabytes per peer per day. It's kind of large amount of data, and we don't know how long we can keep this data online if we plan to go for 700 peers over the period of time. And these are the rough list of peers we have. Some of them UNET and 7 from Geneva, RIPE NCC ourselves, 2 peers from Frontier Global Center, a couple of them from EPINIC, a couple of them from Gigabel, and another one from Frontier Global Center. You might notice that we have peering with 2 locations with the same autonomous systems, which was not initially what we thought of, but after doing this, we saw that we do see some interesting effects due to the IGP mesh and how long it takes to propagate from one end to other. And so then we said, okay, that's an interesting stuff. We should go about with that. And so if it's a faraway locations, we try to peer with the same autonomous systems numbers. And then we have presently developed the Perl scripts and the CGI interface. This roughly look like something like this, which will be formally announced at a RIPE 35, which is in a couple of weeks in Amsterdam. What you essentially see is that you can send 2 types of queries, one based on network prefix, other one based on AS origin, so where the prefix is origin. Then you can specify a period of time which you are looking for, and then you can either look for all updates, announcements and withdrawals, or individually. The last box you see as a peer is a drop-down box which shows the list of peers. So you can either choose from any peer or selectively a peer. And when you enter this as a search, the output is something like this, which essentially you see is the first part of the output is taken from a RIP snapshot, which shows these are the routes which was available in the beginning of the day, and the next is incremental deltas, what you see on the chart. So each of these updates, we note the prefix and the time at which this was arrived at us, and the pier from which it was listed in the AS path. So this information is actually possible to replay it in a sequence, some of the tools like MRT and the BGP simulation, so you can recreate the routing state at any given time if you give the plus this BGP attributes. So this query format and this tool is still under development, and we are looking for feedbacks as soon as we announce it, or if you have any particular interest in to see some data, which a lot of the stuff which Craig was mentioning could have been actually seen here, like the 30-second routes announcements, and you will actually see the n factorial problems of that oscillating here in the patterns. And then what we saw some interesting results from this running this prototype. This is again what it shows on the y-axis, x-axis is the date, which is running from 15th November till 20th February. And the y-axis is prefix updates or withdrawals. So this was Craig has again mentioned a couple of years ago. The scene was just opposite. The withdrawals was more than the updates, announcements. Now the scene is reversed, and as we can see everywhere, number of withdrawals is far less than what has been announced on the. Some of the blocks are quite wider if you notice it. That's because the collector was shut down for some reasons like software crash or hard disk failure or something like that. Since we are still in a prototype stage, we have some of those problems still. And this another part of what we observed is like if this period is this again another graph with a period is same as that, and the y-axis is number of prefixes we see. So the blue one is S1221, which I have taken from Jeff Houston of Telstra, and the green one is AS3333, which is RIPE NCC, and the red one is if we take all 7 peers which we had during that period and take a union of all the prefixes which are announced, it's actually far more than what every individual peer can carry. But if we plot all these 7 individually, what we see is the difference is minor, couple of thousand off by, but collectively the difference is quite high. And for example, the Oregon root collector today has something like 110,000 prefixes. So there are a lot of border routers out there which are carrying large number of prefixes. I don't know how many of you have filters, like if it is more than 75,000 or above some number, stop it or things like that. So this is something to look at it before doing that. And other is the distribution of number of prefixes. It was sometime mentioned that it's the maximum number of prefixes you see /24. It's more than half of it. This is taken again overall of 7 peers, union of them. So there are more specific peers out, prefix out there up to /30 and even /32 are there. So well, this is just an interesting thing we saw. So we're still looking for more peers to cooperate with us and get the BGP feeds from us. Initially, we'll be running with the eBGP sessions from different points. As soon as we have the boxes at exchange points, we'll focus on all the peers at specific exchanges. So I hope some of you will be interested in volunteering the peering. So please contact me or send us a mail. We will not announce any routes back to you, nor forward any traffic. You could announce all the default free route to us, and we will log them up. Any questions? You can find more details of this slide or contact details out here.
Can we have the lights down or up or something, whatever they are now? Could you turn the lights up? I don't think we have any questions anyway. Thank you, Anthony.